Let's dive into an example of raycasting with JavaScript. Join me at your preferred JavaScript code editor, such as jsitter.com. And we're going to begin here by creating the HTML for our web application here. The web application is going to draw a rectangle on the user interface and also follow the mouse to then cast a ray from the mouse pointer and connect it to the walls of the rectangle. Our first step will be to draw walls, and we'll use the HTML canvas for this visualization. In our HTML, we're going to create a canvas tag. Let's set the ID to canvas. Let's set the width of the canvas to 800 pixels and the height of the canvas to 600 pixels. Then we'll close the canvas tag. This is the canvas where we're going to draw the visualization. Then in the JavaScript tab, we're going to reference the canvas by getting the element with the ID of canvas from the document. And we're going to then get the context of the canvas with the getContext function of 2 dimensions. Next, let's define our walls. This will be a list of objects. Our first object will have properties x1 and y1, x2 and y2 with values like 100, 150, 300, and 150. Then we will repeat that again with x1, y1, x2, y2, this time with 300 by 150 and 300 by 350. So we're defining the edges of the walls or the box. Then we'll add another object with x1, y1, x2, y2. And finally, one more object with x1, y1, x2, and y2. This defines each of the corners of our walls. Next up, we can build out a function called draw. First, we're going to clear the canvas from 0, 0 to the width and height of the canvas. We'll do that by clearing the rectangle, and that is on the context variable or constant. Then we can build a helper function called drawWalls, and we'll call that function. Let's create the function, and we're also going to call draw when the page is loaded. In drawWalls, we can set the stroke style of the context. For example, this hashtag 000 for a black color, then line width of 2. And for each wall in the walls list, we're going to begin a path, move to the wall x2 and the wall y2, or rather x1 and y1. That's a starting point. And then we're going to draw a line from the x1, y1 to the x2, y2, and then call the stroke function to draw the line. And you see in your browser, if you resize it, then you have these lines being drawn on the screen. You can also adjust the values of your x1, y1, x2, y2 to change the size of the box or the coordinates. For example, here I can adjust my top left edge to be at the x coordinate 0, and we have the y coordinate 150 or 10 as the x coordinate, and you'll notice that the rectangle will resize. We can also adjust the other edges of the rectangle by changing the other x1, y1, x2, and y2 values. And you can play around with different rectangles of different sizes. That is the walls of the box. Coming up next, we're going to continue our project and get the intersection to cast rays in JavaScript. Let's continue in the next lecture. In this lecture, we're continuing our project of ray casting with JavaScript. We're going to begin to draw the rays or cast the rays with the help of getting an intersection as well. So in our project, we're going to add another function and we'll call it cast rays. Here, we're going to loop over starting at 0 and ending at 360. So each degree in a full circle, which is 360 degrees, and we'll get the angle by taking the index times pi divided by 180. Then we can create a ray represented as an object with mouse.x, mouse.y, mouse x plus math, the cosine of the angle times 1,000, and for y2, the mouse y plus the sine of the angle times 1,000. And we'll define the mouse, which is going to be the mouse cursor on the screen. We'll define the closest variable and the record. The closest will start at null, record will start at infinity, and we'll later define the mouse and then be able to handle mouse movement as well. Then we're going to loop over each of the walls and we're going to get the intersection passing in the ray and the wall. For this, we will have to build a helper function called getIntersection to do the task. Let's build that before it's being called. We're going to define x1, which will be the wall's x1 coordinate. Same thing with y1, x2, and y2. We're getting the start and the ending coordinates of the wall. We're also going to get the x3 and y3 and x4 and y4, which will be the rays coordinates from the starting to the ending coordinate of the ray. And that will be the ray drawn from the mouse to the box. Then we're also going to define the denominator, which will be x1 minus x2 times y3 minus y4 minus y1 minus y2 times here the x3 minus x4, which is the formula for the denominator. If the denominator is 0, we will return null because we cannot divide by 0. Otherwise, we're going to define a constant t, which will be x1 minus x3 times y3 minus y4 minus y1 minus y3 times x3 minus x4. Make sure your parentheses are correct there, and divided by the denominator. Then we implement the formula for the u constant, which will be similar, but it's going to be here the negative of x1 minus x2 times y1 minus y3 minus y1 minus y2 times x1 minus x3 divided by the denominator. Here we're using the established formulas for the t and the u constants, which will be used to get the intersection. If t is greater than 0 and t is less than 1 and u is greater than 0, then we'll define the point, which will have the x coordinate of x1 plus t times x2 minus x1, the y coordinate of y1 plus t times y2 minus y1. And again, that will be part of this formula for the intersection. We're going to return the point as the intersection, otherwise return null. There is no intersection. That's between the ray and the wall. And then that's being put to use here when we cast rays. For each wall, we will get the intersection of the ray and the wall. And next up, we're going to put that point to use to actually cast the rays and draw them on screen. Now that we have the intersection, join me in the next lecture.